We shall begin Chapter 11 of Mathematics Class 12, Three-Dimensional Geometry, Direction Cosines and Direction Ratios of a Line. Now in Chapter 10, Vector Algebra, we have already defined direction cosines. We said that we know that every line makes some angle with x-axis, y-axis and z-axis. And if we take cos of those angles, then they are called direction cosines. Suppose a line makes the angle alpha, beta and gamma with the positive x, y and z axis, and then cos alpha, cos beta and cos gamma are the direction cosines. Now the same definition we shall rewrite here, that is direction cosines of a line are the cosines of the angles made by the line with the positive direction of the coordinate axis. Coordinate axes are x, y and z axis. DCs are denoted by LMN. DC means direction cosines. We denote them as LMN. That means L equal to cos alpha, M equal to cos beta and N is equal to cos gamma. Alpha, beta and gamma are the angle made by the line with x, y and z axis in the positive direction. Now relation between direction cosines of a line. Now we shall establish the relation between the direction cosines, that is between L, M and N. Consider a line RS with direction cosines LMN. So we take a line RS whose direction cosines are LMN. That means the line makes angle alpha, beta and gamma with x, y, z axis, the positive side of the axis. Then L will be equal to cos alpha, M will be equal to cos beta and N will be cos gamma. Okay. Through the origin, draw OP parallel to RS and take point PXYZ on the line. Now this RS is line here. Now we draw from origin line which is parallel to RS. So this is the line O to P. This line is the parallel to RS, and we take a point P on the line, on this line XYZ. Okay, P point is on the line. Its coordinate are X, Y and Z. If you draw the perpendicular from P on the x-axis, then this will be AP, right? And this will be OA, and this distance will be nothing but the x coordinate. That means O to A will be x coordinate. Let OP equal to R. So that is position vector of P with respect to origin is R. So OP is equal to R. Now this triangle AOP. Okay, I'll draw here once again. And this angle, the line OP makes with the x-axis is alpha. So this is this angle will be 90 degree, and this I have redrawn here. So this is triangle AOP and this angle is 90 degree. This angle will be 90 degree. Okay, this angle is alpha. Then OP we are taking as R, and this O to A will be X. Now in this triangle you apply the trigonometric ratio for cos alpha. So cos alpha will be adjacent side divided by hypotenuse. So adjacent side is OA and the hypotenuse is OP, right? So write that applying the trigonometric ratio in triangle AOP. So cos alpha equal to OA by OP. OA value is X. So put here X. Divide by OP is R. Now this cos alpha is the direction cosine. So put this value as L equal to X by R. R transfer over here. So here it remains X is equal to L into R. So this is the X coordinate of the point P. Similarly, we can get Y value as MR and Z value as NR. Now we square these values all three and add up together. So X square plus Y square plus Z square equal to right hand side also L square R square plus M square R square plus N square R square. From here you take R square common. So here remains L square plus N square plus N square. But we know that X square plus Y square plus Z square is equal to R square. So if this value is R square, so we can say that L square plus M square plus N square is equal to 1. So that is the relation between the direction cosines. That is L square plus M square plus N square is equal to 1. Direction cosines of a line passing through 2 points P x1 y1 z1 and Q x2 y2 z2 are, if you are given 2 points x1 y1 z1 and x2 y2 z2, then the direction cosines, if you want to write, then it is written as this formula: x2 minus x1 by pq, then y2 minus y1 by pq and z2 minus z1 by pq, where pq equal to under the square root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Now second is direction ratio. That means let us define direction ratio. So direction ratios of a line are the numbers which are proportional to the direction cosines of a line. So direction ratios are the numbers which are proportional to the direction cosines. So L, M, N are the direction cosines, and suppose A, B, C are the direction ratios. Then the relation between them will be L by A is a constant, M by B is a constant, and N by C is a constant. Okay. If L, M, N are direction cosines and A, B, C are direction ratios of a line, then how to connect direction ratios and direction cosines? So that is given as L equal to A by square root of A square plus B square plus C square, M is equal to B by square root of A square plus B square plus C square, and N equal to C by square root of A square plus B square plus C square. So this is the relation between the direction cosines and direction ratios. Let us solve the exercise 11.1. Question number 1. If a line makes angles 90 degree, 135 degree, 45 degree with x, y, z axis, find its direction cosines. Here, these are the angle made by the line with x, y, z axis. So this angle is alpha equal to 90, this angle is beta equal to 135, and this is gamma equal to 45 degree. Since direction cosines of a line making angles alpha, beta, gamma with x, y, z axis are, these are the direction cosines: cos alpha, cos beta, cos gamma. Okay, so let us put the value of alpha, beta, and gamma. So therefore, DCs of required line are cos alpha is 90, so cos 90 is 0 equal, and then so this value is 0, and cos beta is 135 equal to cos, this 135 can be written as 180 minus 45. 180 is pi minus pi by 4. Okay, this is pi minus theta, that means this angle is in second quadrant. In second quadrant, cos is negative, so this can be written as minus cos 45. Cos 45 value is 1 by root 2, so this negative comes minus 1 by root 2. Okay, cos 45 value is 1 by root 2. Then cos gamma is 45, so 45 I have just written in radian, cos pi by 4. Cos pi by 4 is 1 by root 2. So the direction cosines are 0, minus 1 by root 2, and 1 by root 2. Question number 2. Find DCs of line which makes equal angles with the coordinate axis. Let a line make equal angles, that is alpha equal to beta equal to gamma. All the three angles are equal with the coordinate axis. Now we know the relation between the direction cosines. Okay, we already derived L square plus M square plus N square is equal to 1. But L is what? Cos alpha. M is cos beta, and N is cos gamma. Okay, so let us place the value. So cos square alpha plus cos square beta plus cos square gamma equal to 1. Beta and gamma are same. Alpha, beta, gamma, all three are same. So instead of beta I'll put alpha, and gamma also I'll put alpha. So this can be written as cos square alpha plus cos square alpha plus cos square alpha equal to, this is 1, 1, 1. So 3 times cos square alpha equal to 1. 3 transfer over here, so cos square alpha equal to 1 by 3. Take square root on both the sides, so you get cos alpha equal to plus or minus 1 by root 3. And this is the same value for cos beta and cos gamma. Therefore, DCs of a line making equal angles with coordinate axis in the positive, that is first octant, are 1 by root 3, 1 by root 3, and 1 by root 3. Question number 3. If a line has direction ratios minus 18, 12, and minus 4, then what are its direction cosines? These are the values of A, B, and C. If A, B, C are direction ratios of a line, then you know how to write, right? L is A by square root of A square plus B square plus C square. M is equal to B by square root of A square plus B square plus C square, and N equal to C by square root of A square plus B square plus C square. Okay, same thing I have written over here, right? And here A is this one, A is minus 18, B is 12, and C is minus 4. So denominator is same. So first I'll find the value of denominator, and we'll call it as a constant value, that is we call it as a lambda. So we find square root of A square. Okay, square root of A square is minus 18 square plus B square, that is 12 square, plus C square, that is minus 4 square, equal to, under the square root, minus 18 square is plus 324, plus 12 square is 144, plus minus 4 square is 16, plus 16, equal to square root of, the sum total is 484. Okay, the sum of this is 484. Square root of 484 is 22. This constant you call it as a lambda. Now L can be written as A by lambda, M as B by lambda, and N as C by lambda, and we put the value of A, B, C, and lambda. Okay, A, B, C is here, and lambda we found as 22. So therefore L equal to A by lambda. A is minus 18 by 22, cut by 2, so equal to minus 9 by 11. M is equal to B by lambda. B is 12, lambda is 22, cut by 2, so 6 by 11. N is equal to C by lambda, equal to minus 4 by 22, cut by 2, so minus 2 by 11. Okay, so this is the direction cosines of the line where we are given direction ratio. Question number 5. Show that the points 2, 3, 4, minus 1, minus 2, 1, 5, 8, 7 are collinear. So here the points are, I call this as A, 2, 3, 4, this as a B, minus 1, minus 2, 1, and this as a C, 5, 8, 7. Direction ratios of the line joining A and B are. So this you got x1, y1, z1, x2, y2, z2, x3, y3, z3. Okay, so let us find for A and B first. Okay, so for here the formula is x2 minus x1 equal to, this is x2 and x1, so minus 1 minus 2, which gives you minus 3. Then y2 minus y1 equal to minus 2 minus 3, which gives you minus 5. And z2 minus z1, that is 1 minus 4, that gives you minus 3, call it equation number 1. Similarly, direction ratios of the line joining B and C. So this is B and C, right? So x3 minus x2, that is 5 minus minus 1 here, equal to 5 minus and minus plus 1 equal to 6. Then y3 minus y2, so 8 minus minus plus 2, so 8 plus 2 is 10. Then z3 minus z2, that is 7 minus 1, which gives you 6, call it number 2. Now from 1 and 2, you check the ratio. So here, see, this is minus 3 and plus 6. Minus 3 plus 6 gives you minus 1 by 2, right? Similarly, minus 5 by 10, which gives you also minus 1 by 2. And minus 3 by 6, that also is minus 1 by 2. So all the three ratios are same. So what we can say that, since all three ratios are same, we can say AB parallel to BC, and as B is common to both, and B is common to both lines, right? So A, B, C are collinear. So that is solution for question 4. Question number 5. Find the direction cosines of the sides of triangle whose vertices are 3, 5, minus 4, minus 1, 1, 2, and minus 5, minus 5, minus 2. Okay, I just draw the triangle with the vertices and I call it A, B, and C. Okay, according to the given order, and I write the vertices. Point A, for points A, 3, 5, minus 4, and B, minus 1, 1, 2. Direction ratios, okay, for the side AB. So I take the points A and B and just using the previous formula, okay, like this formula I write for this, and that I call it as a A1. So A1 equal to minus 1 minus 3, that gives you minus 4. Then B1 is 1 minus 5, that gives you minus 4. And C1 is 2 minus minus plus 4, that gives you 6. If direction cosines of AB are L1, M1, N1, right? So we know the formula we used here. L equal to A by lambda, M is equal to B by lambda, and C equal to C by, N equal to C by lambda. Okay. So same way here I can write L1 equal to A1 by under the square root. You know what is lambda. Okay. We have found square root of A square plus B square plus C square. So same way for here, L1 equal to A1 by square root of A1 square plus B1 square plus C1 square. And similarly M1 equal to B1 by lambda. This value I call it as lambda. And N1 is equal to C1 by lambda. Right. So let us find this value of lambda first. So lambda equal to under the square root minus 4 square plus minus 4 square plus 6 square. Okay. This A1, B1 and C1. So equal to under the square root minus 4 square is 16 plus this also 16 plus 6 square is 36. Equal to the sum of this is 68 under the square root. Find the square root, it is 2 root 17. Therefore, direction cosines of a line of a side AB equal AB, L1 first. L1 is, you know, it is A1 by lambda. So A1 is minus 4. So minus 4 by lambda is 2 root 17. Cut by 2, so you get equal to minus 2 by root 17. Then second one, M1 equal to B1 by lambda. So B1 is minus 4 divided by lambda is 2 root 17. Cut by 2, so equal to minus 2 by root 17. And N1 equal to C1 by lambda. So C1 is 6 divided by lambda is 2 root 17. Cut by 2, so you get 3 by root 17. So this is for side AB. Similarly, we shall find for BC and CA. So for B minus 1, 1, 2, minus 1, 1, 2, and C minus 5, minus 2. Direction ratios, same way like previously. So A2 equal to minus 5 plus 1. Okay, this one. Minus and minus plus 1 here equal to minus 4. B2 will be minus 5 minus 1, that is minus 6. And C2 is minus 2 minus 2, that is minus 4. Now here I already called lambda, so now I'll call mu. Okay, if mu equal to under the square root A2 square plus B2 square plus C2 square equal to under the square root minus 4 square plus minus 6 square plus minus 4 square equal to under the square root minus 4 square is 16 plus minus 6 square is 36 plus minus 4 square is 16. Find the sum, it equal to under the square root 68, same as the previous one, and the square root of this is 2 root 17. Now direction cosines of the side BC equal to L2 equal to A2 by mu. A2 is minus 4 divided by mu is 2 root 17. Cut by 2, so you get minus 2 by root 17. Then M2. b2 by mu. So b2 is minus 6 divided by mu is 2 root 17. Cut by 2, so minus 3 by root 17. And 2 equal to c2 by mu. c2 is minus 4 and mu is 2 root 17. Cut by 2, so get equal to minus 2 by root 17. Right? Next, for points C, minus 5, minus 2 and A, 3, 5, minus 4. This side, okay, side CA or AC. Same way we can find, first we'll find the direction ratio, that is A3 equal to 3 minus and minus plus 5 gives you 8. B3 equal to 5 minus plus 5 gives you 10. C3 equal to minus 4 minus and minus plus 2 gives you minus 2, right? Now we find here gamma, okay, I took here lambda, this first one we took lambda, then second one we took mu, so here I'll take gamma, okay, some other number equal to under the square root a cube plus b, so a3 square plus b3 square plus c3 square, okay, a3 it is equal to a3 is 8, so 8 square plus b3 is 10 square plus c3 is minus 2 square, and this is all under the square root, gives you equal to under the square root 8 square is 64 plus 10 square is 100 plus minus 2 square is 4 equal to under square root 168. The sum of these is 168. Find the square root, it is 2 root 42. Now the direction cosines of the side CA L3 equal to, you know, it is A3 by gamma. So A3 is 8. So 8 by gamma is, this value is gamma is 2 root 42. Cut by 2, so you get equal to 4 by root 42. Then M3 equal to B3 by gamma. B3 value is 10. 10 and gamma value is 2 root 42. Okay, cut by 2, so you get 5 by root 42. M3 equal to C3 by gamma. So C3 is minus 2 and gamma is this value 2 root 42. Cut by 2, so you get here minus 1 by root 42. Okay, so this is for side CA. So we have calculated for all the three sides of the triangle the direction cosines. Here we end the exercise 11.1. We'll keep this much for today. Thank you very much.